Welcome to Brain Vision.
16.38. So we have two sinusoidal waves of the same frequency sent along a string in the same direction. One of them has an amplitude of 5 millimeters and the other has an amplitude of 8. So we want to find the phase difference that results in the smallest amplitude of the resultant wave and what that amplitude is. We want the phase difference that results in the largest amplitude of the resultant wave and what that amplitude is. And we want to find what the amplitude is when the phase difference is equal to half the difference between those two. So there's a figure in the textbook that illustrates these things, 16-13. But we know that if we had two waves of the same amplitude, that if they're pi radians, maybe draw this in a different color. But if they're pi radians out of phase with each other, then if their amplitudes are the same, the resultant wave is going to have an amplitude of 0. Since the amplitude has to be positive, then this is as small as it can get. And it's not too difficult to just intuitively convince yourself that in order to get the maximum cancellation for two waves that have different amplitudes, but the same frequency, this phase difference still needs to be pi, so that they're 180 degrees out of phase. Because if there were anything other than this, then you would have, for example, you wouldn't have the situation here where the maximum negative of one corresponds with the maximum positive of the other, and so even just that would imply that you're left with more than the minimum somewhere in the resultant wave. So now in this case, because they're exactly out of phase, we can actually see graphically from this, you can just subtract the two amplitudes and to find the resultant one. So 8 minus 5 is 3 millimeters. Now similarly, the maximum resultant amplitude, it's not any more of a stretch of the imagination to realize that if you have two waves of the same frequency that are the zero radian phase difference between them, that will result in the wave with the maximum resultant amplitude. Then that's also the case for waves with different amplitudes. And so in this case, again, we can just add them. And 5 plus 8 is 13 millimeters. Then for our last part here, so we want phi 1, which we said is pi, minus phi 2, which is 0, divided by 2. So clearly this is pi over 2. Or yes, pi over 2 is also 90 degrees. So then if we think about these two waves as being phasors, so let's call that one 2 and this one 1, for example, then the resultant between them is just the the hypotenuse of this right triangle that they're forming. because of just the rules of vector addition. So then this is 9.4 millimeters.